Hello everyone, welcome to our presentation on the CO2 Dragster car project. My name is Jose Lara and I am currently enrolled in Engineering Architecture 2 at Joliet Central High School. The CO2 Dragster project involves the design and construction of a CO2 powered car. The goal is to get the designed CO2 Dragster into the winner's circle by beating your opponent in races. In order to design and produce a functional CO2 car, the topics need to be researched and practiced are weight reduction. When an object weighs less, it is easier to move, so making the CO2 core lighter will result in a nice fluid fast motion. Although, reducing too much weight might cause the car to break when it impacts the pillow broom barrier that will stop the car after it crosses the finish line. So I want to make sure to keep enough material to avoid my dragster from breaking. Aerodynamics. Aerodynamics is the study of air motion. My goal is to take advantage of laminar airflow to reduce drag on the CO2 car. Drag will cause my CO2 car to slow down, and in this project, we want to maximize speed. This project requires several elements for the construction and designing process of the CO2 dragster. These include hand sketches, 3D models and working drawings, physical construction, and of course, the CO2 dragster races. After understanding what is required of me and what elements I should look out for, aerodynamics and weight reduction, I began to produce my first sketch of my CO2 dragster custom body. This hand-drawn sketch includes a front view, top view, and right side view with size and location dimensions. My thought process when drawing this custom body was to make the car as small as possible, but also thick enough to the point where it won't break on impact. I estimated my size dimensions based off the wooden block given to us in the beginning of the project. I will later use this block of wood to cut out my custom body. Something that I want to point out is the shape of my car. The roundness shape is great when it comes to laminar airflow, because there isn't any rough edges or stops, the air will just have to move alongside the body. This will greatly reduce drag. The next step of the project is to use hand sketches to model the body in Inventor. I began modeling my body by first modeling the block of wood given to me in the beginning of the project. I would then use subtractive extrusions to cut away at the block into a rough outline of the shape. Next, I began to use the spline tool to get the outlines of the curved parts of my body. I would follow this by using the hole tool to make the axle holes, eye screw holes, which are visible in the screenshot, and the hole for the CO2 canister. I used several fillets to round the edges of the custom body. Finishing off the body, I painted the material dark gray and used small extrusions made using the spline tool to individually color the parts differently, as you see in the screenshot. Next up on the project is the assembly. I was provided the wheels, struts, axles, and eye screws, and the CO2 canister, and had to make sure to assemble to see what the finished product will look like. I started the assembling process by grinding the CO2 dragster custom body, making sure the body wouldn't move throughout the assembly process. I will then use several different joints to assemble the car. For example, I use an insert joint for the CO2 canister to the body, and rotational joints for the wheels to the axles. In order to create the explicit assembly of my CO2 dragster, I use a tweak tool to pull apart the parts of the assembly. During the making of the explicit assembly, I noticed that my front axles and back axles were labeled the same in the parts list, which is located at the top right corner, and labeled the same when I ballooned the parts. I came to the realization that this occurred because, during the making of the two different axles, I made a copy of the back axles to use as a basis for the front axle model. But the thing is, I never changed the name of that model. Despite the front axle part file being called axle body, Inventor registered both axles as the same part. In order to solve this, I made a quick part notes and wrote the correct mass and volume values for both of these axles. The updated drawing turned out to be a little different compared to the original drawing that I made for the custom body, which is natural because a big part of engineering is to make revisions and constantly update a part to make it even better. You will see this happen later again in the presentation. Now, the two big changes between both drawings is the overall shape and size of the body. Dimensions such as overall width shrank compared to the first iteration of the car. The shape also changed a bit. This can be seen in the front of the car. In the updated version, the head is much thicker compared to the thinner head in the first drawing. Small changes such as the location of dimensions also occurred. Because I added new dimensions such as the fillet radius, I needed to move the old dimensions found in the old drawing. This can especially be seen comparing both drawings' front and right side views. Now that I have completed the technical aspects of the CO2 Dragster project, I move on to the construction of the custom body. I printed a 1:1 scale drawing of my custom body without dimensions, cut it out, and placed it over the block of wood I was given earlier. I would then trace the image onto the body and make holes through the paper to mark the center of the axle holes that are supposed to show me where to cut once I use the drill press. With my body now outlined on the piece of wood, I was finally able to begin the cutting process. I went down to the Joliet Central's wood shop and used several of the machines there. I first used the drill press to make the holes for my axles, and right after making the holes for my axles, I would jump to use the bandsaw machine to make several leaf cuts, which you can see the results of it in the top right image. Finishing up my custom body, at least for now, I use an oscillating spindle sander machine to sand in the leaf cuts and smoothen out my body. The results can be seen in the bottom two images. The body turned out better than I expected. It was smooth and ready to be painted. As a quick note, if you want to watch footage of me using the machinery, except the bandsaw, the videos are uploaded on my portfolio. But as soon as I saw my competition, I knew that the painting process would have to wait. My competition was much more smaller and thinner than my custom body, and if I wanted to keep up with the rest of the CO2 cars, I would have to make some changes. My plan was simple: make the body even thinner. As you can see in the image on the left, I wanted to trim the top of the backside of the front view and cut the parts in the sides in order to make my body even lighter. The results were great, and now I was confident I could at least win one of my races with this new and improved body. With the cutting process out of the way, I was now able to move on to the more artistic side of the project. I started by drawing the flame design on a piece of wood with a pencil to get a rough idea of what I wanted. After getting the results I was looking for, I grabbed the sticky note, traced the shape of the body onto the sticky note, and then copied the design I drew on it. Next, I grabbed the pair of scissors and began to cut out the designs. I grabbed these cutouts and stuck them to the body with tape. These sticky notes were to keep the gray paint that made a majority of the color from getting into the areas reserved for the navy blue and sky blue paint. After painting the body gray, I took off the sticky notes and grabbed a skinny paintbrush for extra precision. Using the skinnier paintbrush, I was able to paint the flames with both shades of blue without accidentally painting over the lines. Once the paint was done drying, I began the physical assembly process by cutting up the straws and inserting them into the axle holes. These straws help reduce friction between the axles and the hard, uneven wood. I followed the straws by inserting the front axles, which were then followed by the front wheels. The hardest part of the assembly was sticking the eye screws. Inserting them naturally with my hand was not working. Instead, instead, I grabbed the pencil to make small indents on the rear and front of the car, and from these small indents, I would be able to comfortably twist in the eye screws. At the end, my CO2 dragster had completely changed compared to the original idea. To summarize, my CO2 dragster was now lighter and smaller than before. Both of these factors were incredibly important in increasing the speed of my overall car. Another important change is that this version of my design is more aerodynamic than I was originally going to make it. Initially, the back part of the car had a much more drastic curve, but in this updated version, the curve is now more fluent and smoother compared to the rest of the body. My, this means that my dragster would experience less drag and more laminar flow. These changes were with one goal in mind: making my CO2 dragster faster than my competition. For my first race, my car was lighter and more aerodynamic than my opponents. When the CO2 canisters were popped open, these elements were what propelled my car in high speeds to win the race. With this victory under my belt, I would move on to the quarterfinals. Similarly to my second race, I won the quarterfinals for the same reasons. My car was lighter and allowed for more laminar airflow than my opponents. With the same elements at play, I was then able to move on to the semifinals. Once I reached the semifinals, things got interesting. Me and my opponent's cars were similar in weight, which initially made me fearful that this might be as far as I can get. But as soon as the CO2 canisters were popped, I saw my car being propelled faster than my opponent's. Despite having a similar weight, my car's smoother, rounder body beat my opponent's much larger, rougher body. This just goes to show how important researching aerodynamics was. I would have not won that race if my car was experiencing drag the entire duration. With the final race upon me, I knew it was a close match. When the CO2 canisters were popped, my opponent's car went flying, leaving my car in the dust. But as soon as my car got to the halfway point of the track, it started to speed up. Despite this boost in speed, my car wasn't able to win. My car was heavier than my opponent's, and my opponent's car was more carefully put together to avoid the most drag as possible. And with this turn of events, I placed second. With those recent results, that just begs the question, what could I have done better? I could have sanded down the rough edges to ensure my body was only experiencing laminar airflow. When my car got the boost in the race, I assumed this was because it was experiencing drag the entire first half of the race, and the car was finally able to get its footing once it reached the halfway point. Something else I could have done differently was to allow for more deeper cuts and play around with my shapes. Perhaps taking a different shape or cutting deeper would enable me to lose more weight and gain the weight advantage over my opponent. This, Despite me not winning first place, I'm quite proud that I was able to get a close second. This project really helped me grasp what it means to be an engineer. My CO2 dragster updating and changing constantly throughout the creation of it is an integral part of the engineering process. This project was a lot of fun to record and experiment with, and that's the presentation. Thank you for your time.